All right, welcome to the final part of Chapter 2. We're talking about neuroimaging examples. So I gave you a couple of examples maybe in the previous couple of videos, but we're going to walk through one and kind of look at how it works. So let's say that we're going to be using fMRI for this example because a lot of what we're going to be reading this semester is through fMRI data because for a lot of the reasons that we talked about. It's easy to, it's relatively cheap. You can use these things to get a good clear-ish image on top of the brain, in the middle of the brain. It doesn't matter. So we're going to be using fMRI for this particular experiment. So what you would be doing in this particular experiment is I'm going to show you an image. There's going to be a face overlaid with a house. And so it is your job to either look for the face or look for the house and focus on that. That's all. All right, so let's look at it. So you pick one of these. You can focus on the face, you can focus on the house. So if you're looking at this image, if you want to, you can focus just on the face or you can focus just on the house. So if you were to do that, you would do that for, like 30 seconds, maybe 20 seconds or something like that. And then it would move on and you would get another example. So you would get something like this, where again, you can focus on either or. But if I am interested in, like face perception, this is a pretty nice design because what I'm doing is I'm telling you to look at the face. And if you're looking at the face, then when I'm comparing this to other control conditions, we have lots of other visual information that you're looking at. So, what this particular article found, this is kind of an old article, but it's a classic, is essentially that whenever people are asked to look at the face, it activates one part of their brain. When they're asked to look at the houses, it activates a separate part of the brain. This is fascinating stuff. Why? Because if you think about it, every single one of us is looking at the same stimulus. And yet, just by having an instruction that changes what part of your brain is going to be active whenever you look at this particular image. If you were asked to look at the face, you're going to have the fusiform face area activated. If you were asked to look at the house, you're going to see the parahippocampal place area activated whenever we look at that. So we can use things like the subtraction method to reason this out, where we would have, we would ask them to look without instructions, and then we'd ask them to look with instructions, and then we would subtract those two out and see what kinds of activation is left whenever you do that subtraction. Here you can see that we're left with just the fusiform face area. Here you can see that we're left with mostly the parahippocampal place area. So here you can see in this particular case where people are asked to focus on the house and then focus on the face. So they're sitting there and then they tell them, okay, now look at the face, now look at the house, etc. And so you can trace this through and you can look at, all right, they're looking at the house and then we're going to tell them to look at the face. So if they're looking at the house, you can see that, they get that instruction, it starts to go up so that they're looking primarily at the house. That area of the brain is activated for the parahippocampal place area, which you can see down here. And then once you tell them to look at the face, then you can see that immediately drops off and their fusiform face area kicks in and goes up, stays up. Again, they're looking at the same image, it's just that one is, they're told to look at the fusiform face area or they're told to look at the house. And we see the exact opposite when we go in the opposite direction. If they're supposed to be looking at the face, then we ask them to look at the house. You can see that again, that the switch happens shortly after those instructions are changed. So that's one example. But let's say that we were interested in other things. Like if I were to ask you, what is the best method to show differences in neurotransmitter production for people with and without PTSD? This one's kind of a tough one. But think about it. Which one would you use? You'd probably want to use PET. You'd want to use PET imaging. Why? Because PET can measure neurotransmission. It can measure what's going on with neurotransmitters. The others that we've talked about this semester, or this video, this chapter, don't do that. So PET would be best here, but if I were to ask you, what method works best whenever you're trying to study how the brain reacts during nightmares? This one is kind of tough. I would say you'd want to go with EEG. I can see an okay argument for fMRI. I don't think it would be the best, but I think that EEG would be the best for what we want. If we were asked which of these would we use to study which areas cause language production, then we could use probably TMS We could probably also use fMRI. I think those would be the best ones to use there. So another example of looking at a rare neuropsychological condition and then trying to figure out what's going on in that part of the brain by using neuroimaging. So the book talks about this in more detail, but it's called the Capgras delusion. The Capgras delusion, sometimes called the Capgras syndrome, is this feeling that people have where they know and recognize the people in their family and their friends, but they assume that those are imposters, that they are people that have been abducted and kidnapped and replaced by complete strangers, which is that's terrifying to think about, right? So you recognize them, you know they're supposed to be your mom or your dad or your brother or your sister, but there's something about them that you're certain that they are not who they say they are. So when people have been scanned and looked to see what's going on in their brain, what they find behaviorally, at least, before we even look at the data, is we find that their perception is fine. That they can detect, oh, this is, their brother or their sister. That is their face. That is their hair. But there's no real loving emotion that's attached to that, and they don't familiarize themselves with them. They don't think that is their family member. It doesn't feel like it's their family member, partly because there is no real emotion connected to that. So why does that happen? Almost always through some kind of neurological damage that happens later in life. Typically, it can be the amygdala is impaired in some way, and that might result in a diminished emotional response. So if the amygdala is hurt, then they're not able to articulate I'm not going to say that they're not able to articulate their feelings, but they're not able to sense their feelings nearly as well. If that is the area that is responsible for fear, disgust, and anger, if it's not really working right, that can possibly affect things like love and feeling good and feeling bad and anger and disgust, etc. So we know based on scans that there's something wrong with the amygdala. So we found that out. We also found out that there's certain parts of the prefrontal cortex that seem to be impaired, so it's not able to communicate with other parts of the brain. So these illogical thoughts, these delusions, are not completely filtered out. That can happen, if you were to damage, like Phineas Gage, part of your prefrontal cortex. So, just like with Phineas Gage, he had that severe brain trauma in his prefrontal cortex. What they found is that people like that have damage there are also going to have problems filtering out their illogical thoughts, both out loud and in person. And so basically what this tells us is that it's kind of a combination of these two things short-circuiting that are going to lead to the Capgras delusion. That is going to that we've noticed this behaviorally, we've verified it with neuroimaging techniques, and now we feel like, okay, if we want to try to treat Capgras delusion, here's what's going on with the behavior and here's what's going on with the brain. How can we find ways to fix or treat or even prevent these kinds of things? All right, that's it for the chapter. Next chapter, we're going to be getting into perception, mostly visual perception, but it'll be a fun chapter. This is where we start getting into the real nitty-gritty, the real sciencey type of things. I'm excited to get there with you, so I'll talk to you soon. Bye.